show that the circle and another circle touch each another. So the word touch tells you that maybe you want to intersect them. So I have x squared plus y squared here, which is exactly equals to 25. So let's substitute. Rearrange. You can divide by 6. Okay. Now what am I going to do next? Okay, let me draw one. This is the smaller circle, and then let's say we have another bigger one. We got to show that they are touching. So what is this 4x plus 3y equals to 25? As I solve them simultaneously, technically it should be the line over here, which belongs to both. Okay, if the two circles meet, then the intersection point must lie on this particular line. So you have to prove it is true for the first circle and it is also true for the second circle. So you rearrange, you will get y equals to, and you're going to substitute that into the first circle. Rearrange, you multiply everything by 9 now. (25) times by 9. I think you can divide this by 25 now. Okay, now we have a quadratic. Let's see what happens. I can write it as, what does this tell you? This is repeated roots. As there is repeated solution, then the line is actually becoming a tangent to the first circle. So let me label this as circle 1 and this as circle 2. You got to do the same thing with the other circle, and you have to show me that you again going to get x equals to 4. If that happens, then I know that the circles are touching. A little tedious, but you try. Can you see what I'm doing? I have a y here and y here, right? So I went and substitute this particular y. Rearrange. Again we will get this. See, you can reduce it into a 6. Okay, multiply everything again with 9. At this portion, at this part, you will realize that you can balance them off, you're going to get 0. Minus 25 times by the 9. I think by now you would have realized it is exactly the same here. So what am I getting? Again repeated root where my x is equals to 4. Okay, I am shortening the step. Now you can write the conclusion. So earlier we have written here the line is tangent to circle 1. Now you can add and circle 2. So the second part of the question says, if they are touching, can you please find the coordinates of the point where they touch? You already know the x value, so substitute into this. Substitute your x equal to 4. Four comma 3. Okay, this is one way of solving this problem. Let's say if you feel that this is tedious, I got to be very careful when I am expanding the expression. If you don't want to do this, then you can solve by inspecting the center and the radius. So let's solve the same problem. You have the same thing. Let's find the center of the first circle. What do you get? You're going to get 0, 0 and your radius is going to be 5. Similarly, you rearrange this. You do the completing of square. What do we get? 100, which is 10 squared. Therefore, your center is 12, 9 and your radius is going to be 10. So, what idea would I want to use now? Okay, see, you have 0, 0 and your radius is 5. Okay, then the other one, you assume that they're going to touch. You draw an image, a geometry circle like this. And then what you're going to do, you're also having another radius here. This is the radius 2, this is radius 1. You are getting it as 10. Can you see it here? 10. And then the other one is 5. Okay, this is 12, 9 and this is 0, 0. So if they are touching, then you know the length joining the center of the circle, this one. This length has to be 15. If it is 15, then I am very certain that they got to touch. See, initially when I draw, I am the one who is making them to touch. Now you don't know. But you know, if you find the distance between center 1 and center 2, and if that value is 15, why am I focusing on the 15? Because I know 5 plus 10, this and this, if I add them up, if it is 15, then I know they are touching. So I am using this particular concept. Of course, I think it's easy. You will definitely get 15 over here. Therefore, you write a conclusion based on this. What can you see? As the combined radius of the circle is 15, then I know the two circles do touch. So since I have proven that they are touching, how do I find the intersection point easily? In order to do this, in the second part, I have to find the point, right? I need to find what is this exact coordinate. You use the concept of ratio. So how does it work? You draw a line. See, you're having a big triangle, right? So let's highlight this using gray color. And you know what is the length of all of these. I know that this is 0, 0, and this particular length is 12, this is 9, and this is 15. I have just proven it to be 15. Then what do? You take another smaller triangle here. Where is that smaller triangle? Okay, we're going to label this as x comma y, which you don't know, you are looking for it. So can I create a smaller triangle here? This is going to be your x and the y, and this is 5. By ratio, you compare the length. Let's see what happens. So I can do y over 9 is equals to x over 12 equals to, compare, 5 over 15. See, this is the 5, this is the 15. Small to big. I'm doing the same thing. Small to big. Small to the big one. Compare by ratio. So easily you will be able to write y over 9 equals to 1 over 3. Therefore, y is equal to 3. X over 12 equal to 1 over 3. X is equals to 4. So the point where the circles intersect is going to be similar to the previous one, which is 4.